Oh, there we go. Okay, so we are in chapter 8. Yeah, that's where we're at. We're at chapter 8, right? And last Wednesday online, we talked about mathematical induction. So did anybody try that yet? Vaguely remember what that's about? Should we do one more example to kind of make sure that we're on the same page? Not yet. All right. Do you guys remember what problem we did? I think we did 12. I feel like we did 12 and 8 maybe, but I'm not sure if we did 10. Is that right? I think we did 8. I know we did 12 because that was the one that I was like, how did I get that to work? And then I got it to work. And I'm pretty sure we did 8. So maybe let's do 10 just to kind of review what mathematical induction is. I also want to tell you that for your, while I'm opening this, for your homework, I want you to do 1 through 13 odd. You can skip 21 and 23. And then I want you to do 43 through 59. So you don't have to do 59, 49. Did I say 49? 43 through 49. So let me type that in the chat so that it's out there. So you're going to do 1 through 13 odd. Yeah, you get to skip 21 and 23, and you're going to do 43, not off, 43 through 49 odd. For section 8.4. Okay. So just to kind of review what mathematical induction is, let's close that. Okay, so mathematical induction is the idea that you are going to prove that a statement about the sum of some series of numbers is true. Okay, so in number 10, there's a series of numbers, and the numbers are 1, then 4, then 7, then 10. And what they're doing to create these series of numbers is it's 3 times the number, like that place, minus 2. So, for example, if you are doing number 10 in the 4th place, it would be 3 times 4, which is 12, minus 2 equals 10. Right? If you wanted to find the 10th number, it would be 3 times 10, 30, minus 2, which is 28. Okay? So that's how you get the sequence of numbers. But if I want to know what all of those numbers added up equal, they're proposing to me that it would be the number of terms that you have divided by 2 times 3n minus 1. Okay, so what I have to do is I have to determine is that true, right? Is that a true statement or not? And so I do that by doing mathematical induction. So for mathematical induction, we need to first prove is P sub 1 true, and then we'll talk about the next thing. So the first thing that you have to do mathematical induction is you say, is P sub 1 true? So in this case, the first number is 1, and then I'm going to plug that in here. If I do 1 divided by 2 times 3 times 1 minus 1, that's 1/2, 2 minus 1. So 1/2, oops, sorry, it's 3 minus 1. That should be 2. That equals 1. So the first term works, so that's good, right? The second part of mathematical induction, hold on, I can't see the chat. There we go. Hey, Connor. The second part of mathematical induction is that we need to prove the truth that P sub k implies the truth of pk plus 1 for every positive integer k. Okay, so what we're actually going to do there is that we are going to we're going to take our terms and we're going to see if it's true or not. So what I mean by that is we have P sub k, okay, plus the next term, which is going to be the k plus 1 term. Does that equal P sub k plus 1? Should be a 1 there. Okay. So where we're going to get these numbers from, okay, this set of terms added together is going to come from this. And this set of terms added together is also going to come from this. So these are going to come from this part of your equation, what everything is added up to. All right. And then the next term is going to come from this part of your equation where you're adding the next term in. That's how we're going to kind of prove that it's true. Okay. So for this particular one, we have P sub k. And so we're going to use the formula that's given when we add up all of our values through k. What does that look like? So it should be k divided by 2 times 3k minus 1. Okay. And I'm going to leave that middle part blank. And then I need to know what happens when I add it to the next one. So it's going to be k plus 1 divided by 2 times 3 times k plus 1 minus 1. So these two terms, the P sub k and P sub k plus 1, are like when you add them all together, what do you get? So we have when you add the first k, what do you get? And when you add the next term, k plus 1, what do you get? Okay. This next term that you're going to add actually comes from here, comes from the next term. So I have all my numbers added up, so I'm going to do 3 plus the next term, which is k plus 1 minus 2. So if I can prove this out to be true, then I can show that that this is a true statement about adding up these numbers, that it's true. Okay, so then what you have to do is just do some math, right? We got to do a bunch of math here, so I'm going to just do this all in black. So I'm going to go ahead and distribute this. I'm going to get 3k squared divided by 2 minus k over 2 plus 3k plus 3 minus 2. And here I get to distribute. So I'm going to do like a mini distribute under here. I've got k plus 1 over 2 times 3k plus 3 minus 1, right? Or 3k plus 2. So I end up with 3 times k plus 1, 3k times k plus 1 over 2 plus k plus 1 times 2 over 2. Hopefully I didn't lose you guys too much in there. So I think what I'm going to do is, I know I can cross those off. I think what I'm going to do is I'm going to multiply everything by 2, and then I'm going to get rid of all of my fractions. So I'm going to multiply everything on this side by 2 and everything over here by 2. And I get rid of all of my 2's. So I get 3k squared minus k plus 6k. And then I'm just going to combine these together. It's going to be 3 minus 2, which is 1 times 2. So plus 2 equals 3k times k plus 1 plus 2 times k plus 1. All right, so should I keep going? You want to see if it works out? Or you guys believe me? 3k squared plus 5k plus 2 equals 3k squared plus 3k plus 2k plus 2, which equals 3k squared plus 5k plus 2. So there we go. It equals each other. So we can prove by mathematical induction that those are true. All right. So that's mathematical induction. Again, Connor, I'm not sure where you joined, but if you look in the chat, I think you can still see it in the chat. At least you can see it on here. I changed the homework a little bit. It's 1 through 13 odd, and then just 43 through 49 odd. Okay. This is the other part that we didn't quite talk about, but let's talk about these examples right here. So this is switching gears a little bit from mathematical induction. We've been talking about sequences, right? We talked about sequences that were arithmetic, and we talked about sequences that were geometric. And I want to talk to you about sequences that are linear or quadratic or neither. Okay. So I want to talk to you about what that looks like. And of all of my examples here, let me see here. I know what the answers for all of those are, and I know which one I want to, let's see. I'm looking something up so that we have a better linear sequence here. Okay, yeah, so that's what I thought. So a linear sequence, yeah, let's do that. So we have a linear sequence, a quadratic sequence, or neither. Okay, so a linear sequence actually has the same properties as a arithmetic sequence. They kind of have the same properties. So if you remember back to your arithmetic sequences, I'm going to go back my notes here. An example of an arithmetic sequence that we could have would be, here we go. A sub n equals 150 minus 7n. Okay, so if I'm following this and I want to write the first 5 terms of my sequence beginning with the given term, all right, so in this one I'm going to tell you that a sub 1 is well, we can figure that out, whatever a sub 1 is. So we're going to start with a sub 1 is what we're going to start with. All right, so if I wanted to write the first 5 of the terms of the sequence, you're literally going to say a sub 1 equals 150 minus 7 times 1. So the first term of your sequence is 143. 143, right? The second term of your sequence would be a sub 2. So it would be 150 times 7 times 2. So that's 136. Your next term is 129, then 122, then 115. So if I write the first 5 terms of my sequence, and then I look at the difference between each value. So the difference between each of these is from 143 to 136, it's -7, -7, -7, -7. So because I have that same number, I have the same common difference, then it's an arithmetic sequence, and we also would say that this is a linear sequence. Okay, so that we've actually learned before. We got that down, right? What we haven't talked about is, look at example 50. Let's get that out here. Example 50. Okay, so it says, write the first 5 terms of the sequence beginning with the given term, then calculate the first and second differences of the sequence. So that's what we were doing. We were calculating the differences. So number 50 is a sub 1 is 0, and a sub n is a sub n minus 1 plus 2n. Okay, so what I'm going to do is I'm going to make a little like kind of chart, right? Your first term, and what is your a sub n? No, I always write that wrong. This should be n. What is your n, and what's your a sub n? Okay, so when your number is 1, your a sub n is 0, right? When your number is 2, it should be, this is your scratch work off to the side, a sub 2 equals a sub 1 minus 2 times 2. So a sub 1 was 0, minus 2 times 2 is 4. All right? All right, so what happens when your number equals 3? All right? A sub 3 equals a sub 2 plus 2 times 3. A sub 2 was 4, so 4 plus 6 is 10. So your third term is 10. Okay? And so on. So if you keep doing that, does that make sense how I was calculating those? Yeah. Okay. So then your next one will be 18, and then your fifth one will be 28 if you keep going. Those. Okay. So it says, write the first 5 terms of the sequence with the given term, then calculate the first and second differences. So let's calculate the difference between each of these terms. So what is the difference between 4 and 0? It's 4, right? What is the difference between 10 and 4? It's 6. What is the difference between 18 and 10? It's 8. What is the difference between 28 and 18? It's 10. So we call this the first difference, okay? If the first difference was, like in that last example, if the first difference was the same, then we would say, oh, well, that's a arithmetic or a linear model. But these first differences aren't the same, right? They go up in a sequence, but they're not the same. So we also need to calculate something called the second difference. Okay, and the second difference is done the same way. We'll do 6 minus 4, which is 2, 8 minus 6, which is 2, 10 minus 8, which is 2. When we get to the second difference, what do you notice? The second difference is the same. The second difference is the same. So when you have a sequence where the second difference is the same, that means that this is a quadratic sequence. It's a quadratic sequence. If you have a sequence where the first difference is the same, which is not the case here, but if our first difference is the same, then it's a linear sequence. Okay, and if you have an example where the first and the second difference are both different, then it's neither, doesn't follow a model. So it's not too difficult to calculate. Excuse me. The reason I didn't do 44, 46, or 48 is because all three of them are neither. So when you calculate the first differences and the second differences, they are not consistent. So do you guys think you could do that? Figure out the model for that?
Yeah.
Cool. Okay. Next. I was just talking about this in my other class. All right. So who remembers probability? Seriously, I was just talking about this. Probability, where you're trying to figure out, there's just, you're trying to figure out how many combinations of shirts and pants and shoes that you can have. That's one type of probability. That's kind of the easiest type of probability. There is the type of probability where you have a number of choices, like you have, I don't know, 20 different markers you can use, and you want to pick 5 of them to use to write a word. So how many different ways can you pick 5 markers in a certain order, right? One of the things that we talked about is that there is something called combinations. So if you wanted to pick, you have your 20 markers and you want to pick 5 of them, right? And the order of the 5 matters. That's when we use something called permutations. I don't know if this is kind of like in the back of your mind somewhere. It was at the end of Algebra 2, so it was when our brains were all getting mushy, right? But when you want to pick a certain number of items from a larger group and you care about what the order is, that's called a permutation. But say that you want to pick 5 markers out of 20, but you don't care which order they're in. And then we use something called combinations, right? And so a combination is a way of selecting several things out of a larger group where the order does not matter. So I don't have it up on here, but let me kind of pull this up and review what that means. Okay, so there it was called, so I don't know if you remember, we had the NPR, like National Public Radio. We had the NPR. That's when you care, you're picky about what the order is. Okay, we don't have to talk about that in pre-calc. But we also have the NCR, which is the number of, you have 20 markers and you want to pick 5 and you don't care if, if it's blue, pink, yellow, or yellow, pink, blue. It doesn't matter to you which order you pick them in. You just want 5 out of the 20. And the formula for finding combinations is that it's NCR, it's n factorial divided by r factorial over n minus r factorial, okay? Where n is like the group that you're sampling from, okay? This is your total sample that you're picking from. And r stands for the number of objects that you actually want. Okay. So I do like some Sharpies, so I probably have more than 20 Sharpies, but so if I have 20 Sharpies, right, and I want to pick out 5 different colors, I don't care what order they're in, I can use this formula, which would be 20 factorial over 5 factorial times 20 minus 5 factorial. Okay, then I can do the math. Let's see. See, I was just doing this in the other class, all coming together. All right, 20 factorial divided by 5 factorial times 20 minus 5 factorial. Okay, so out of my 20 markers, and I want to pick 5 where I don't care which order they're in, I could pick 15,500 different combinations of 5 markers. It's a little crazy. But some colors don't go together, so we can nix some of those out of there, right? Also remember that this idea of picking certain items is a mathematical principle. So in Desmos and in your graphing calculator, there is a button that lets you do it. So you can also do the NCR, which is the number of combinations. So you have 20 different markers and you're picking 5, and you end up with the same. It's just a pre-populated formula. Is that vaguely in the back of your brain somewhere? So another way to write that, sorry, I just want to make sure. Another way to write that we didn't talk about before is that you could write it like this. Kind of looks like a matrix. You have 20, choose 5. Oh, and that's a way to say that. 20, choose 5, 20, choose 5. So you have 20 markers, you choose 5. We're not worried about the order. Okay, and so you can see that up here, we're going to talk about a binomial theorem, which has to do with that. But you can see up here that here is the formula when you're choosing items. It's written right there for you. It's a little bit written in slightly different order, but the same. And that this n choose r, so the number choose r, is written in this way too. Okay, so that being said, the first problems are just to find the number choose r. They're calling it the binomial coefficient because what we're going to do with this is we're not using this whole idea of combinations. In pre-calculus, we're not using it to choose the number of Sharpies or the number of songs or the number of people on a committee. We're going to use it to expand binomials. Sounds exciting, right? So instead of picking the number of, picking the number of items, we're going to use it to do something else. So these should be fairly easy. Let's just kind of go through a couple really quickly. Okay. So, for example, find the binomial coefficient, right? If you have number 2, and I find these fun in my head to think of fun things. So you have 9 items and you want to choose 6 of them. How many combinations are there? So to do this, you would do 9 factorial over 6 factorial times 9 minus 6 factorial. All right. If you really don't want to use a calculator, you can do this fairly easily, right? So this is 9 factorial over 6 factorial times 3 factorial is what this is. So 9 factorial is 9 times 8 times 7 times 6 times 5 times 4 times 3. Make my paper bigger. Times 2 times 1, right? Over 6 times 5 times 4 times 3 times 2 times 1 times 3 times 2 times 1. So now you get to cross off, right? 6, 5, 4, 3, 2, 1. 3 goes into 9 3 times. 2 goes into 8 4 times. and 1 just kind of there. So we've got 3 times 4, which is 12. 12 times 7 is 84, right? So 9, choose 6 is 84. So some of these you can do by hand. So if you wanted to check in Desmos, of course you could do that. You have 9, choose 6, 84. Okay. What if you have number 4, which is, oops, you have 20 items and you're going to choose 20. How many combinations of that do you have? I'll be off with you off to the side. Okay. So number 4, you have 20 items and you're going to choose 20 of them. All right. So what does this mean? You'd have 20 factorial divided by 20 factorial times 20 minus 20 factorial. Okay. So one thing that we would have to know then is what is 0 factorial? Because we have 20 minus 20 is 0, right? So 0 factorial is actually 1. So this becomes 20 factorial over 20 factorial, which is just 1. So if you have 20 things and you're choosing 20 of them, you just have one choice, basically, right? What do you think this one would be? If you have 18 items and you're going to pick 17 of them, how many different ways that could you do that? So you have 18 and you're picking 17 of them. So that's 18 factorial over 17 factorial times 18 minus 17 factorial. Well, 18 minus 17 factorial is 1 factorial, which is just 1. So I get 18 factorial over 17 factorial, which happens to be 18. There's 18 different ways to pick 17 items out of 18 items. All right. So the closer the two numbers are, the bigger the number is, right? If you're going to pick a lot of the items out, so this was 1, this is 18, right? Over here, if you're going to pick one item out of 14 items, you have 14 different choices. But if you're going to pick 15 items out of 20, you'll have 15,504 choices. Right? So it kind of just depends. Like the closer you get to the ends, the lower the number, because there's either less choices that you're having or less combinations, right? The more that you get to like if the middle, then the more that you get. 11, 13, 14, 16, it says using graphing utility. I would definitely recommend that. You don't want to be writing out factorials. So in Desmos, again, you're going to go to function. You know, if you want to find, for example, number 40 or number 11, which is number 11 was you have 41 choices and you're going to pick 36 of them. Okay, so just to kind of show you again, you're going to go to functions, stats, number, choose. So the C is for choose, and you're going to say 43, choose 36. No, 41. Sorry, 41, choose 36. Okay. If you are using your TI calculator, you're going to go to math, and then you're going to go over to the right. There's something that says PRB, which stands for probability. And then the third thing down under the probability under the probability menu is NCR. Okay. So we are, oh my goodness, the time. Let me give you a quick preview of what we're going to do with this on Monday. Okay. So We're having so much fun. So here's the question. If I wanted you, wow, that's beautiful. Just kidding. If I wanted you to, let me just pick one of these. Pick this guy. Okay, so I have y minus 2 to the 5th power. This is a binomial, right? A binomial means that you have two terms, and this is to the 5th power. I just mixed up my numbers. A binomial means that you have two terms, right? And this one happens to be to the 5th power. If I asked you to expand this binomial, could you do it? You could, right? You could do y minus 2 times y minus 2 times y minus 2 times y minus 2 times y minus 2. What are you going to have to do? You're going to have to do a whole lot of FOIL in order to get this done, right? You're going to need to FOIL these two together and then FOIL these two together, and then you still have this on the end. So, you'd have y squared minus 4y plus 4 times y squared minus 4y plus 4 times y minus 2. So now you used to have three terms. Now you've got to distribute this to everything in there, and then you've got to distribute that. So even though it looks super simple, y minus 2 to the 5th power, if I asked you to expand that out, that problem is going to take up at least an entire page of work, right? Because you're going to have to be doing all kinds of distributive property. And I like the distributive property, but that's a whole lot of distributive property. But if you want to do it, go for it, right? So some really smart mathematicians a long time ago came up with something called the binomial theorem. Okay, so if you want to expand a binomial that is x plus y to the n power, right, you can expand that theorem, that polynomial, by writing x to the n power, then n times x to the n minus 1 times y plus blah, 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 plus NCR, n choose r, x to the n minus r, y to the r, blah, 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 plus nx y to the n minus r plus y minus n. Okay, the coefficient of n, I think there's a typo on this one. Yeah, it should say n minus r, yr is this. So the whole idea of like choosing the number of objects is great, but it also helps us with the binomial theorem so that we don't have to do this gigantic FOIL distributive property problem. Okay, so we can actually use it to expand our numbers, and it's not super duper too scary. Okay, so what this would look like for this particular problem is we're going to get rid of this, sort of. Take that away. Okay, we're going to take that away. And what it looks like, and we'll practice more of this on Monday, is that you're going to do this. So instead of writing it as instead of writing it as NCR, I'm going to write it like this, where this is N and R. Okay, so we have 50 times y to the 5th, and then we have -2 to the 0 power, plus 5 choose 1 to the y to the 4th, -2 to the 1 power, plus 5 choose 2 y to the 3rd times the -2 to the 2nd power, plus 5 choose 3 y to the 2nd, negative 2 to the third power plus, oh, that shouldn't be dividing right there, sorry. Just have it. Y, or 5, choose 4, y to the first, negative 2 to the fourth, plus 5, choose 5, y to the 0, negative 2 to the fifth. So once you simplify all of these things, right, you evaluate what 5 choose 0, 5 choose 1, 5 choose 2. You evaluate all those and then you simplify the terms, then this will actually be the expanded version of y minus 2 to the fifth power. Actually expand it out. Okay? So that's what we're going to do on Monday. So you get a little sneak preview of that. Exciting, right? All right. So I think we're going to stop there because that was so much fun. I appreciate you guys coming today. We will wrap up 8.5 on Monday, which means that we'll actually be done with chapter 8. So all right. So thanks guys for coming today, and I will see you on Monday.